So like I said, you're going to have the exam key available to you. But I do just want to kind of, hard to talk over. So I do want to just go ahead and, oh, we got green dots on there again. Take a look at each one. So question 1 was, now these were the best answers. So, do you have a question? Okay. So question 1 was about circumpolar stars. And to me, the best answer there is A, that actually circumpolar stars are stars that will always remain above your horizon. Okay? It's not true that circumpolar stars are necessarily even near the North Pole, depending upon your latitude. Clear that up. Okay. Question 2 was a question about the moon, and you were supposed to pick which one of those were true. And this one actually, and this might be, when I think of taking it out of less than, where's my clear the board? When I think of taking it out of less than 50, or excuse me, 74? Yeah, taking out 70 instead of 74. Question 2, I wish on the review sheet I would have put weight and mass, because one of the things we talked about in lecture was weight and mass, the slight difference between those two things. Not that slight, right? A weight is what you measure in the morning when you step on a scale, and that would be different on the moon and the Earth. Okay, mass would be the same. So the best answer there is C, that your weight would be actually less than if you're on the moon than compared to on Earth, but your mass would be the same. So C is the best answer there. Question 30, drop something off of a tall building, if you have a green hat on or not, it's going to go faster and faster, and by the end of 3 seconds, it should have picked up 3 sets of 10, basically. So it should be running about 30 meters per second. Oh my gosh, I found a typo in mine. So I would take A. If you guys picked C, okay, come and see me after class, because actually C is the right answer. You guys can see C, I obscured it, but C has the right units of how fast it would be falling. Darn it, okay? So for question 3, I will take A, because I put it as A. Darn it, go back. A or C. Okay, any questions about that? Oh, there's my little erase thing. Okay. Okay, so for question 4, talking about the North Celestial Pole, and you can use it actually, the best answer was B there. You can use the altitude in your local sky of the North Celestial Pole, which is Polaris right now, and that will be the same as your latitude. Question 5 was an example where, can you see that B actually for question 5 was the green ones that circled? And it talks about a cue ball, and you take it and you hit it with your stick, okay? And I think the best answer was basically you are imparting a force on that ball, and it accelerates from a speed of 0 to a certain speed. Okay, so that's F is equal to ma. So I thought B was the best answer, but I got to thinking, and actually I would take any of also A or C, and I tried to hand check that. Okay. Question 6 was a question about the universal law of universal gravitation, this one, okay? And it actually was a question about the D term, and we talked in class, and you guys kind of intuitively told me if you have a green and a gold ball, and you're talking about the force of gravity between them, what this says is that if the distance is increased, and I put the up arrow there, then actually the force will go down. Just increase the distance and the force goes down. Okay? Next page. Clear that screen. So the best answer for 14, and it didn't have the word moon in it, but the best answer for 14 is that the reason we have tides is because of the gravitational influence of the moon. Okay, so. Oh, I did. Thank you.
I was like, wow, I must have not been paying attention.
Where?
Yeah.
Thank you. Okay, so I didn't really put this one on the review sheet, but what I was hoping that, as the Earth spins, that's why we have day and night. And so along those lines, 7, the best answer is there. C, we experience nighttime because the side of the Earth we're on is facing away from the sun. Question 8 what is the acceleration of gravity here on Earth at about the Earth's surface? And you could either go with 10, remember, or 9.8. And here the units of acceleration are meters per second, or meters per second squared. So the best answer for A is C. For question 9, okay, question about that backward motion of planets. And the best answer there is B, that why it occurs is basically the Earth is passing another planet. And the planet it's passing appears to go background with regard to the backwards with regard to the background stars. Question 10. The planets go in an elliptical shape, which Kepler came up with, right? And since it's not a straight line, it's accelerating. And according to F is equal to ma, the acceleration needs to be caused by some force. And that force, of course, is the gravitational pull the sun has on the planets. So I was after D for 10. Question 11, which of these are not accelerating? Okay, so the best answer there is A, that you are driving a straight line at a constant speed. So A is the answer for 11. Question 12, if you take a picture of a galaxy that is 1 billion light years away, then when you finally get the light and image your photo, that's today's time compared to, okay, that was as the galaxy was 1 billion years ago, because it took 1 billion years to get here. It's located 1 billion light years away. So I have a couple of questions about related to 13. So with regard to where are we are on the Earth. Our Earth is part of a system of planets called a solar system. Our star is a member of the Milky Way galaxy, and then galaxies are grouped together in what we call the local group. And then our groups are clusters of galaxies are further clustered into superclusters with a local supercluster. And the last term up there is universe. So C was the best answer there. So now on to 14. All right. Okay, so yeah, so why do we have tides? And the best answer there was, and it is related to the moon, but it's the moon's gravitational influence on those large bodies of water. So the best answer is D. Question 15 was kind of like question 13, I think. Basically kind of looking at relative perspective, yes, from smallest to largest. It goes planet and then star, okay, because an example of a star is the sun. And then solar system is the star and the planets. And then stars are part of galaxies. So that's the best answer there. Question 16, why did Ptolemy have those Loop-De-Loos? And that was C, he was trying to explain retrograde motion, basically. So that's what's being described there in C. Question 17 is a question about seasons. When we have summer here in the northern hemisphere, they're having winter in the southern hemisphere. And the best answer to that is that D, the northern hemisphere is tilted toward the sun, and it's about the directness of the rays from the sun that gives us summer, or indirectness of the rays of the sun that gives us winter. Question 18, absolute zero on the Kelvin scale is 0 Kelvin. So A is the best answer for 18. Question 19, it talks about an object moving in a straight line at a constant speed. And it says, according to Newton's first law, which says an object will remain in motion until acted upon by an outside force, the best answer there is D, that object going at 50 miles per hour straight will continue to move in that direction until or unless it's acted upon by an outside force. So D is the best answer there. Question 20, most of the mass in the Milky Way is located outside of its plane in the halo region. Best answer there is C. Flip, right? Question 21. Why is Polaris so special right now? And it actually is our pole star in the northern hemisphere. It's very near the North Celestial Pole. 22, so that's A, best answer is A for 21. 22, who discovered that Jupiter has moons? That would be C, Galileo. Question 23, galaxies are moving away from us, and the more distant the galaxy, the faster it's moving away. Can you say raisin bread? So the best answer there is C, that it indicates that the universe is expanding. Question 24, if you're standing on the equator, so 0 degrees latitude, and you're trying to find Polaris, Polaris will be at the horizon north. Okay, so the best answer there is A. Question 25, so the moon gives us tides, but there are certain times when the sun kind of works against the moon, and that would be when the moon is at a right angle as the sun. That would be at the quarters. Question 26. So this was actually, 26 was kind of similar to what the Apollo mission did, dropping a feather and a hammer. Okay, 26 is. So basically this scenario says you're going to drop a golf ball, which weighs significantly less than a bowling ball. And you'd either have to make them aerodynamically similar, or like this problem says, remove the effect of falling through the air. So the air resistance isn't going to be an issue, okay, which is why the moon worked so great. And honestly, I know that it sounds counterintuitive, but they would hit the ground at the same time, okay? They would accelerate at the same time and hit the ground at the same time. So C is the best answer there. Question 27, which of these is true about the moon? A, B, C, and E are incorrect statements for one reason or another. But it's true to say that D, perigee and apogee occur. Yeah, perigee, the moon is closest to the Earth, and apogee, the moon is farthest from the Earth. The other ones are not true. Question 28. He discovered that the planets orbit in the shape of an ellipse. That would be Kepler, again, E. Question 29, has Polaris always been the North Star? And in the margins I put precession. Actually, that's a question coming up. Polaris has not always been the North Star. And as I kind of make my hand go like this is the wobble of the Earth's tilted axis of rotation. So, question 30, I would take either A or C. Originally, I was just after A, but I got to looking at it, and those are very similar. Okay, so talking about Kepler's second law, describing the motion of the planets around the sun, I was really after A. Basically, a planet will travel fastest when it's near to the sun, and it'll slow down when it's at what we call aphelion, fastest at perihelion, slowest at aphelion. And I got to looking at C, and it says planets that are farther from the sun move at a slower average speed than near the sun. I think what C is talking about is literally the orbits, a different track. So, but to me it's kind of similar. It feels like it's talking about perihelion and aphelion too. So, like I said, I'm going to post these. I'm going to scan them in and post them. The average distance between the Earth and the Sun is referred to as an astronomical unit. The ecliptic, or the plane of the ecliptic, marks the path that the Earth orbits the Sun. Celestial sphere is that imaginary sphere with the Earth at the center and the stars imprinted on it. Question 34, I was after kinetic energy as the general term that we associate with the motion of an object. Opposite of kinetic energy is potential energy. 35, I was after precession as that kind of wobble of the Earth's tilted axis of rotation. 36, Occam's razor is kind of the keep it simple, stupid, but I even picked, if you put KISS, I took it. I thought that was kind of cool. Okay, well, a hallmark of science is that don't get it too complicated. Question 37, we say an object is accelerating if it changes its velocity, which has both a speed and direction component. So I was after acceleration. Parallax is what I was after for 38. Okay, as a result of parallax, a nearby object will change its position, and I really was kind of thinking of the tree, the nearby tree and the distant mountaintops. So that nearby object changes its position as the observer moves. The next question, momentum. Isn't that funny? Okay. Momentum is, remember, everything that's in motion has momentum. That's kind of what I described there. And it's calculated by taking the object's mass times its velocity. And the last one, a hypothesis, is kind of what you start with in the scientific method. Test it, test it, test it, test it, and if it passes, elevate it or king it. I'm going to turn this this way. Can you see yourself? All right. So we can fit it all in one page. So these were each worth 3 points apiece. And honestly, I tried to be consistent as I graded them, but everybody's a little bit different with regard to matching up with what I was after. Okay. So like for instance, oh, interesting. Come on. Oh, there it goes. Nobody breathe. No, I'm serious. You can breathe. So the first one, for instance, to me, the kind of the crux of it is that they're trying, a light year is a unit of distance. And when it asks the questions, what's wrong with using a light year as time, that's what's wrong with it. Okay, so how old is the universe? Okay, it would be not right to use the term light years. Okay, that's what I was after there. For the next one, this was a homework question, 42 wasn't it? Briefly explain why, when we look at objects that are further away, actually we're seeing them, baby pictures of them. So I was after something about the fact that it takes light a certain amount of time to get to us. So each were 3 points. For question 43, notice that you need to explain why. If the Earth's axis of rotation were straight up and down and wasn't tilted 23.5 degrees, we wouldn't have seasons. I agree, but I asked why. And so, to me, the best thing, what I liked, and I saw it in a lot of people's, was it's about an angle thing, or it's about a directness thing. Like, question 44, that band in the sky we call the Milky Way. And I take an assortment of reasons there, but I kind of put that we're looking into the disk of the Milky Way galaxy, lots and lots of stars. Question 45. Remember we had that one figure in your textbook that had the sun and the earth and then the zodiac constellations outside in a ring? Okay, so those constellations, actually, if you look at a sky map, the zodiac constellations lie in the ecliptic. They lie in the plane where the sun's going to pass. Okay, so it's a very specific set of constellations that fit that bill. And my thing is that Ursa Major, which actually, within Ursa Major is the Big Dipper, right? You're not going to find, the sun's never going to pass through that because that constellation is not an ecliptic. That's kind of what I was after there. The next one is kind of an interesting thing. You had to read it a couple times, but I was wanting you to kind of think outside the box a little bit. So the scenario for 46 is that you have made it to the moon, and you're standing on the moon, okay, and I kind of drew it here. Not just anywhere on the moon, but you're on the near side of the moon. And by the way, a lot of you got this right, which is great. And it's a lunar eclipse, which means it's a full moon, and basically the Earth's shadow is going to be cast on the moon. So you can kind of see in my description, what's going to happen is the Earth's disk is going to cover up the sun's disk from your perspective. Basically. So, I know somebody put that, like, you get that blood red sensation, and that's true, too. So, they were, again, each were 3 points, and I tried to kind of, a lot of times you only got one off, so then these are kind of straightforward, Newton's laws and Kepler's laws. Newton's laws of general motion and Kepler's laws of planetary motion. Okay. So, there you go. Yeah, this video will be posted, but also probably more to the point is going to be the thing you can print out under doc sharing, the answer key. Because remember my final exam? You're going to see some of these questions again. Okay? No. So you can get them right the second time. Get them right the first time and the second time. And I'll remind you when we get closer to the final, but a lot of times I pick the ones that I'm like, oh, 10 years from now, I hope they remember that. So I don't know. The other thing is when we get closer to the final, I'll have a review session for the final in which I will pull up these unit exams and kind of tell you the possibility of which ones made it to my final. So that's kind of fun. Okay?
Did you say that the final exam could substitute in for a really crappy test score?
Yep. Yeah, the final exam.
Is that just in this class or is that in all your classes?
That's in all my classes.
Okay.
It's my way of handling, because stuff happens, it's my way of handling a missed exam too. But yeah, in all my classes.